All right, thank you very much. Well, quite a few of you came. Thank you for that. I was slightly worried about giving this speech, and while preparation, I was speaking to my AI assistant about how can I get into my hard Slavic accent so that English audience can get me right and understand. And you know what told me? It told that you now can tell them that your pitch is AI verified, hence it's top notch. So now you know. Well, let's get started then. My name is Anton. I am the delivery director at Yalantis. Yalantis is a customer software development company. And for the last 8 years with my team, we have developed over 100 custom solutions in data, into artificial intelligence, into IoT, Internet of Things, IoT domains. And today I would like to share a really interesting case from our recent partnership. But before we get started into that, my marketing team asked me to keep the presentation rather official and just add one meme at the beginning and the agenda slide. And I believe it's even better because today we'll be talking a lot about how necessary proper data quality, how necessary proper data foundation. And this slide, I guess, kind of describes the agenda of my pitch today really nicely. So let's get started. As I mentioned, I will be talking today a lot about our recent partnership with a global tobacco manufacturer for whom we recently developed a solution on example of which I will explore with you why potentially you might not necessarily need AI yet, or what other aspects and things you should be taken care of while planning your next AI project, your next AI adventure maybe. Typically customers came to us, IT service companies, in two main reasons. First, when their level of uncertainty is that small, like they know exactly how to build a thing, they know exactly what they want to get, and then they just need to free up some resource internally to kind of focus on the things that they want to focus on, some new innovation and some expansion and so on. But the other scenario when customers came to us is that when their level of uncertainty is that high, like they know nothing, it's something new field for them, and they want to explore, they want to understand what kind of new innovation they can get from the new technologies, from the new opportunities, and so on. And that was exactly the case with our customer, because they came to us with the request of exploring AI capabilities. They want to know what this technology could bring to them, and they wanted to explore with different companies what innovation could they bring to the table for them. And it's not surprisingly, because when you manage in a supply chain department of a global tobacco manufacturer with over 50 production facilities around the globe, and tons of goods being moved around the world daily, your questions should be really conservative. You should be asking yourself, like, what kind of change should we gain? What we want to gain from this next innovation, right? So that was the case with our customer, and we made a number actually of sales pitches, case studies, one-on-ones, workshops with our technical specialists, and so on and so forth. And at some point, we understood that actually for them, at their scale, the biggest challenge is data quality. Like at their scale, they have an entire team that on a daily basis form a huge file of around 100,000 unique values for proper analytical processing. Like they verify data quality, data completeness, fullness of records, and so on and so forth. And imagine they do that on a daily basis, manually. I know that here in Birmingham you guys have a beautiful library, so it's as if librarian would on a daily basis get inside all the books manually with some paper and just a pen, and trying to sort it out where to put each book on the shelf. That's how good. So it became clear to us that if only AI could bring any sort of value for this organization at that level, it should be something that is related to addressing that data quality issues. Like, we should start from there. So that became clear, but still we were talking about multinational organization. Like, literally, their list of goods is longer than my hometown telephone directory. Like, where to start? What's the starting point? So we, with the customer, decided that we need a plan. We need some strategy how to tackle it down. And the plan was pretty straightforward. It was consistent of three main pieces. At first, we decided to find out a really good measurable use case in their supply chain, some pain, but which is kind of addressable with their data quality concerns. Then, on top of that use case, we decided to build some workable proof of concept that could kind of serve or confirm that particularly this use case is addressable and it could bring some value. But the third one was actually planned for further populating of this use case once the previous two are completed to the production with a reasonable attention to their data foundation and with proper setting up of ATL operations, data pipelines, and so on. So, quite simple, I guess. It was pretty straightforward, and it was so, yeah. So, that was the plan, and we started researching the options for the use case. Among the options, we had quite a few, like inventory optimization algorithm with optimization of leftovers distribution logic on their stock, or it was also warehouse capacity management algorithm as well with distribution of goods to shelf logic and optimization. But the final decision or the final use case was actually provided or chosen for ocean lead time delivery prediction. So we decided to help them to address level of accuracy with which they plan their deliveries across the globe in an ocean delivery. And it's kind of not surprisingly because over 40 vessels they have in the ocean on a daily basis with the different providers, so different carriers. Over 15 global and local carriers provide for them services in the different regions. So that was quite a challenging thing for them to gather all the data from different carriers in one place and get the picture like all over the globe. So it's also worth mentioning that they already had at that moment third party that was gathering the data for them, but it was rather static data. Like they would only have a list of vessels that they have in the ocean at the moment, but no actual prediction, no accuracy detection. At the same time, as all of you probably experts in logistics, you know that from this parameter, accuracy of ocean lead time delivery, many other internal operations heavily dependent, like warehouse capacity management, inventory planning, last mile delivery, and so on, you name it. So that was our plan that we wanted to achieve with that POC, and we built a POC actually with three components. At first, with dynamic rules of Apache Airflow, we built a data quality guardrail. As I started initially, data quality was a fundamental challenge for them. So we, with this system, addressed the data quality concerns and tried to reasonable degree, automate rules of data quality operations, or at least provide them a visible highlights on where those potential data issues might be stored. You can see here on the dashboard, it's a lifetime table that shows to the very each record where the potential duplicates, missing values, and all the potential data concerns might be stored. With this in mind, we wanted to make sure that further AI models that we will be using is of the highest quality of data possible, because it's really vital part whenever it comes to any AI-related project, the quality of data. Then the most, I guess, valuable part for them was actually carrier's efficiency dashboard. For this one, we built a custom ML model, machine learning model, that would compare the provided estimated time of arrival from carrier with the actual position of the vessel in the ocean and the remaining part. So essentially, what we did, we took a historical data from their recent shipments. We were able to get, unfortunately, just 6 months horizon with perspective of data, and brought a number of associated with that delivery data parameters, like weather condition, vessel type, dock loading, and so on and so forth. So essentially, we try to guess what kind of parameters could impact on the possibility of delay of the particular vessel. And then our data scientists team, iteratively, we made 4 biweekly iterations, try to get what exact parameter has the biggest impact on particular delivery, kind of retrospectively. For that, we built a custom ML model. You can see them here listed on the screen, and they are ranked with the biggest impact on the possibility of delay. Obviously, it wasn't a surprise that vessel type is the most critical data parameters that impacts. Like, there are vessels that always late, probably older or maybe less, powerful. And there are vessels that are always on time, freshly, assembled and so on. But then, as you can see, such parameters as ocean wave height or direction of wind that also impact, and that was a surprise. And the aim of this iterative approach was actually finding out which combination or like mixture of this parameter could bring the highest level of accuracy. I will be telling about that just in a second, about a few other results that we gained. But also, on top of that model, we delivered for them carrier's golden carrier selection model. As I mentioned before, we also wanted to provide them some decision-making helping as they choosing the particular carrier for particular route. And using the same model, we provided this sort of alternative source of truth. So essentially, anyone on the team with selecting route A, route point A, point B, would get the insight which carrier for this particular route in this particular period of time would be the best one that could keep the delivery time as they promised, that could make the delivery on time. And here below you can see that each of these decisions was kind of supported, or suggestion was supported with historical data that we extracted from their previous deliveries. Yes. I mentioned before that we were trying to find the best combination of different data parameters that would maximize the level of accuracy of our prediction. So as you can see, for different regions, we have a number of them. Pretty much all of them except just one, the average level of accuracy was 70%. Frankly speaking, we didn't have set KPI, as it was just a POC, and we were mutually with the customer exploring what's the best approach and what could we get out of this kind of endeavor. But it's funny that the same model with the same weight of data parameters was equally distributed for all of the regions. So technically, in the future, if only we deploy this model for each region separately and explore in detail different weight factors for each of the regions, we can expect that this this prediction delivery would be even more accurate. At the same time, as you can see, for pretty much all the regions, it's higher than 70%, while their experts provide them level of accuracy 75%. So we nearly approached the same level of accuracy as the experts that providing them the same, but we did that automatically, just based on the historical data that we get out from them. You might be wondering what also could kind of enhance or increase the level of accuracy in future. As I mentioned, we only got 6 months period of data, so this would be the biggest potential for further enhancements. Such logistics spikes as Chinese New Year, for example, in February, doesn't include it in this range because we only got data from May to October. So definitely expanding this data range from 6 months to 1 year or ideally a couple of years would drastically change the game. And a number of other parameters, we can talk about them later once I finish the Q&A, but definitely expanding the data, the higher data range you have, the better. That's what's matter. But then you might be wondering, how do we ensure and how do we verify with them that our predictions are accurate? So the last model of this POC was actually post-mortem lead time dashboard. At this one, we were comparing 3 parameters. Actual date when the delivery happened, not even date, but duration, right? Then initially predicted by experts data range of the delivery, and prediction that was provided by our model. And as I mentioned, for different regions and even for different routes, level of accuracy is different. And that's why we wanted to provide them, and even for us, for our own record, some workable tool that could make sure that they can continuously verify, and we with them as a technical partner could continuously explore where, in which locations or even regions there is a room for enhancements. And those parameters that I showed before, they could be helpful as we would explore with them this room for further enhancements. Then that's where we ended up with our POC. I will be telling about further plans just in a second. And we briefly touched on the technical stack. I already mentioned Apache Airflow, that was data orchestrator. The whole data warehouse was set with Snowflake, so everything was stored there. The visualization part we powered with Power BI, and it was quite easy and fast in terms of UI, so we really focused on the under the hood logic rather than on bringing the AI in place. And that's it. So just in 10 weeks, we were able to build AI core that later in a further production deployment wouldn't change. I mean, the model itself would remain the same. There are some iterative approach with enhancement, the weight of parameters and further deployment to different regions, but the core is just the same. But the interesting part that plugging in the proper data on the production when it comes to the point would take us 4 to 5 months. So literally each data source that we plugged for this POC manually, to automate this supply, we will need 4 to even 3 times bigger time range and effort, obviously, than building AI core or ML core. And I guess that's the most valuable insight and the message that I wanted to deliver, that you saw that AI was responsible for prediction and it really worked well. But still the good effort was spent for proper ATL, extract, transform load, operations building, and data quality automation, even on the POC stage. And only in a combination, those two kind of clicked into place. So that's my main takeaway, that building AI is hard, any kind of project. But bringing proper foundation for it, it's always harder, especially in a bigger organization and where you have some siloed historical data and so on and so forth. So as a takeaways, I have few points, kind of lessons learned that we learned for us and I want to share with you from this partnership. So at first, do not kind of focus on the AI, focus or think about data at first, which you will be using for your project. Secondly, to start with some POC, with some workable use case, and the narrower this use case, the better. Then start thinking about data quality early in your POC stage, and then scale it responsibly. And the verification approach that I showed, we believe that's the best one, so you can choose the POC use case and then scale it accordingly. So that the last statement would be that I started with the topic, you might not need actually AI unless you thought enough about data foundation. That's all I got. Thank you very much. We have a booth over there, so if you have some questions, we can discuss them there, or we can discuss them now. Any questions? Thank you very much.